Okay, we are talking about intersections, okay, mainly the traffic control devices. We have read about or we have gone through the warrants, okay, the criteria of sight distance in normal conditions as well as with a stop sign. Then we talked about traffic signals, okay, which can be handled or operated in different ways: pre-timed, coordinated, fully actuated. Okay, we talked about the terminologies, and then we talked about a method to quickly find out if the capacity of the intersection is enough or not. We call this method as the critical movement analysis. Okay, now we are moving on to operational analysis of traffic signals. You have big car, right? Big car.
Big car, okay.
You have, right? Yeah.
Yeah.
You can have a folding chair in the car and you can carry it with you. What's the problem? Why? Or like they have the child seat, you can bring your own seat.
Child seat,
Huh?
so one of those
I said like a child seat, not a child seat. Huh? You can like keep an extra seat in your car, you bring it with you, and it will be easier for all of us. Okay. So we are now moving on to the, you have another problem, like you are waiting for me to just move on, huh? Now you are doing it intentionally. Oh my God, calculated. Yes, done. Huh? You are done or not? Sure. So operational analysis means finding out level of service. Okay, and using the level of service, you can do the design as well. Okay, we didn't do it in this course, but we did do it in the previous course, traffic engineering course. Again, using the level of service. Okay, just to give you a hint, for example, you want level of service C on the highway or on the intersection. Okay, and you do your design. After design, you check, am I getting level of service C or better or worse? If you are getting worse, then you can change your design. Okay, this is how we can use the level of service concept in for the design. But anyways, so once you know how to find out the level of service, you can use it for design. Okay, so how to find out the level of service? We need input data, obviously. We have to find out movement groups, lane groups, and flow rates. Okay, basically you should know flow rate for each movement. So we are talking about an intersection, right? You can have different movements: right turn, left turn, U-turn, movement. And these movements can happen from different lanes, right? You can have 2 lanes for left turning, you can have 1 lane for right turning. Okay, so we should know the flow rate for each movement and the lane from which this flow rate is happening, and if it is divided, how much it is divided. Okay, there are 2 lanes and how much of the flow rate is divided. Okay, then find out the adjusted saturation flow rate. Okay, I explained it last time as well. Saturation flow rate means the maximum flow rate, and we are talking about signals. So this is the maximum flow rate from a signal, and it's ideal because it does not take into account the stopping. Okay, the red is not included, so this is why we have saturation flow rate, which is ideal. What are the adjustments? We will talk about. How do we adjust it? We will talk about. Find out proportion of vehicles which arrive during green phase. Okay, some of the vehicles arrive during green and some of them arrive during other timings. So what is the proportion? Find out the signal phase duration. This is only for actuated signals. Okay, actuated means what? It's with a sensor. Okay, if it is with a sensor, find out the duration of the signal phase for that volume. Then find out capacity and volume to capacity ratio. After finding it out, you can find out delay and level of service. Okay, so these are the steps we should follow. What is the input data we need for level of service of a signal? Demand or volume? Okay, basically we need volume or demand, and it should be for each turning movement. For each movement we should have a different value. Okay, you cannot tell me, okay, volume on this highway is 4,000. It's not enough to know the total. I want to know how much for each movement. Okay, and for each movement you should also know the percentage of heavy vehicles. Okay, so having total volume is not enough for doing the operational analysis. You must know the volume for each movement, and for each movement you must know its percentage of heavy vehicles. Other thing which you need is the geometric data of the intersection. Geometric data includes, for example, the width of the intersection in each direction. Okay, width in this direction, width in the other direction. Number of lanes you have, lane width, turning radius, all this is part of geometric data. And then signal timing data. You must know the signal timing data. Clear? How much is the green, how much is the red, how much is the yellow, and obviously this is for each phase. Then again, total is not enough. You say, okay, total cycle time is 120 seconds. Okay, then from 120 seconds, how much for each phase, and in each phase how much for the green, how much for the yellow, and how much for the all red. Okay, so these things are required in detail. Okay, this is showing you how we can differentiate between movement, or how we can make movement groups and lane groups. Okay, remember, so you have the data, you know how much volume in each direction, and you know how many lanes are there for that direction. Okay, and then you see how many movement groups or lane groups you can make. Okay, so movement groups are those which move during the same phase. Okay, they have to. Let me rephrase it. Movement groups consist of those lanes which have to move in the same phase. Why? For example, this one. Okay, there's only one lane. There's only one lane, and all movements are happening in the same lane, right? So even if I give a phase for this one, left turning, or the straight, I have to open this lane, right? I cannot separate. Okay. What about these two? So I have how many lanes? 2 lanes, right? Okay. Can this and this move separately?
Yes.
Yes. This is only for left turning. This is why I told you to come with me at 11 o'clock. Now you are late. Forget about the lecture. Okay. So these two are different. This is one movement group, this is another one, because these movements can be separated from each other. Got it? The movement, not movement. These lanes can be separately opened. Okay? So they will become 2 movement groups. Got it? Okay? And as I mentioned earlier, you can have a group of 1 lane. So we are calling it a group, but this group has how many lanes? 1. This group has how many lanes? 1. Okay. Now look at this one. How many lanes we have first of all?
2.
2. Okay. So why are we not making it 2 groups? What's the reason?
Because all them at the same time.
You have to open them at the same time. Why? Because both of them have what? Same movement. So you cannot open this lane which is going straight in one phase and stop these guys. It's not possible. Okay? So the movement group has a common movement. Okay? So you cannot separate them. Because of this common movement now, they cannot be separated. Okay? So they have to be in the same group. Clear? Clear? Okay. Now look at these two, they have same movement. They have to be together. Look at these two, these three. There are three, right? So can I make these two separate and this one separate, the last one? No, because of same movement. Okay? So any lane which has the same movement as the other, you have to put them in the same movement group. If the movements are completely different, they will be in different groups. Clear? Okay? If a lane or number of lanes have completely different movement from the others, then you can put them in one group. So for example, if let's say all 5 of them are on the same road, okay, these two have completely different movements than the others, so they will be in one group. These 3 have a common movement, so they have to be in one group. So they group 1, group 2. Clear? Clear? Okay. So this is how we make movement groups. You have to see which lanes have completely different movement than the other. If they have even one common movement, they have to be in the same group. Clear? Okay. Okay. Then the last column shows you lane groups. Okay. The difference between lane groups and movement groups is for movement groups we are looking at the movement, right? In lane groups we look at the capacity. We look at the capacity. Okay. This one, no problem. Obviously one lane. It will be one group, obviously. Now look at these two. This lane is for left turning. This lane is for straight and right. Can they have same capacity? They cannot. Okay, because the maximum number of vehicles which can turn left will be less than the maximum number of vehicles which are going straight. Okay, so the capacity of these lanes is not the same. Okay, so this will be one lane group, this will be another lane. Okay, we had how many lanes we have? 2. We put them in one movement group, right? Because there was a shared movement. Can we put them in same lane group? No. Because movement from this lane is different. There's a left turning, right? There's a left turning. So it will have a different capacity than the lane which has straight and right. Clear? So we have to make them in 2 lane groups. Okay? We are looking at the maximum number of people, right? So maximum, if a lane is for straight and left, the maximum number of people who can go from there are different than the other lane which goes straight and right. Clear? Okay. Then here, same movement group, same lane group. Okay, both of them are left turning, no change. Here I made one movement group for all 3 of them. Why? Because of this common movement, right? Can I put them in the same lane group as well?
No.
So how many would I have?
2 same, 1 different.
Yeah, these 2 will be same. Okay, so total I have 3 lane groups, right? This is 1 because same movement. This is 2, same movement. This one will be the third one because it has 1 extra movement, right? Clear? 1 extra movement. Okay. So let me summarize. Movement group is made by looking at common movements. If there is one common movement in the lanes, at least one, then they will have to be in the same movement group. Movement group. Clear? Lane group is reverse. If you have one different movement, it will be in a different group. Okay? So movement group, at least one common movement. Lane group, whenever you have one different movement, you have to put it in another group. Clear? Okay? So in lane groups, all movements should match. In a lane group, all movements should match. Okay? If you have both lanes, if you have 2 lanes, okay, then both should be in the same direction. Okay? Two lanes both in the same direction. Yeah. Even if one extra direction is there, you have to put it separately. Okay. But in movement group, even if one common movement is there, it's enough. Clear? Any questions? Okay. Second thing we do is find out saturation flow rate. Okay. Saturation flow rate, I showed you last time as well, previously. Saturation flow rate is a maximum flow rate, right? Okay. So saturation flow rate or any flow rate is inverse of the headway. Saturation flow rate is inverse of the headway. So if you want maximum flow rate, the headway should be minimum. Okay. So we call it saturation headway. Maximum flow rate is called saturation flow rate, and minimum headway is called saturation headway. Clear? Okay. So you can. There are methods to find out flow rate. Methods to find out saturation headway on a signal. We discussed in the previous course. Okay. You can take it from the field observation. You have to go to the field and you have to find out the minimum headway. Okay. There's method to observe it. Anyways, so you take the inverse of that thing and it becomes saturation flow rate. Okay. In some of the books, they have given some recommended values as well, which you can see over here. Okay. So 1,700 for urban location. 1,900 for urban locations. 1,700 for rural areas. Okay. These are recommended values. If you want your own value, go and observe minimum headway. Take the inverse. It will be your saturation flow rate. Clear? Okay. This is the base value of saturation flow rate. The base value. Then you apply adjustments to the base value to calculate adjusted saturation flow rate. Okay. So the base value comes from where? From the inverse of the headway. Then on that base value, you will apply these 10,000 adjustments. Okay. Okay. So what are these adjustments? S0 is the base value. Okay. The base value you get. And then you multiply all the factors with the S0. What are these factors? The first factor is for lane width. Okay. The first factor is for lane width. The second factor is for heavy vehicles and gradient. Okay. Then we have a factor for parking lane or parking activity near your lane group. Okay, if you have roadside parking. Okay, not a parking garage or something. Okay, if there's a near your lane group, if you have a parking area where you go off the road and into that area, this is not considered. We are talking about roadside parking. So you go from the road directly in the parking space, and you come from the park, you are on the road. That type of thing. Okay. So if you have this something like this, then you have to apply the adjustment. Then the blocking factor for the local buses. If you have a bus stop near the intersection, then if you have a factor for area type. Area can be urban or rural. Okay, there are adjustments for that. Adjustment factor for lane utilization. We will use it in some other question as well. If there are two lanes for the same movement, traffic will not divide equally in these lanes. Okay, so this percentage in which the traffic is dividing is called lane utilization factor. Okay, so lane utilization factor is a percentage of distribution of traffic. Okay, in different lanes which are going in the same direction. You have two lanes, both going straight. Okay, so what percentage of straight movement is in one lane and what percentage is in the other lane. Okay, so this is called as lane utilization factor. Factor for left turning vehicle presence in the lane. If your lane has a left turning movement or not. Okay, factor for right turning movement. If your lane has a right turning movement, there is a factor for that. Factor for pedestrian and bicycle adjustments for right turning groups only. So this factor is only applied for right turning traffic, because then pedestrians and bicyclists can cross you, right? Okay, you are on a signal, you are taking the right turn, so maybe the signal in your direction is red, so pedestrians are crossing. Okay, so this can happen. This is only for right turning. Factor for work zone, we discussed it in the freeway case as well. Work zone means what? Construction activity. Okay, and so factor for that, and we already have seen the equation to calculate this factor. Okay, factor for downstream lane blockage. Now downstream it means what? Before or after? Take a sip. Take a sip. Take it. Now tell me. Okay, so you have 3 lanes for example, but after the intersection one of the lane is blocked because of some activity or anything. Okay, so factor because of that. Adjustment factor for sustained spillback. What is a spillback? I showed you a video earlier. If intersections are very close to each other, okay, so I'm at this intersection, I want to move forward, but the queue in the other segment is very long, so it is doing what now? It is blocking the intersection. This is called a spillback. When once the queue from the next segment, the downstream segment, blocks the upstream intersection, this is called as spillback. Okay, so a spillback condition is the one in which the queue is blocking your intersection, so you cannot move forward even if the signal is green. Clear? This is called as spillback. Now you can see all these conditions do not apply at the same time, or may not apply at the same time. Okay, for example, you may not have any bus stop near the intersection, so this factor will not apply. Okay, you may not have any spillback, so this factor will not apply. You may not have any work zone, so this factor will be taken out. Clear? Okay, so you don't have to apply all the factors. You have to look at your lane and you have to see which factor should be applied. Clear? Okay, from where do I get these factors? These are the 2 tables. Okay, for most of the factors. Okay, there is which factor is missing, you will tell me. Okay, so just pay attention here. Factor for lane width. Based on the values of the lane width, this is the factor. Okay, and obviously this is the factor which will apply in all cases, right? Your lane width could be this or this or this, right? So this you have to check in all cases. Factor for heavy vehicle and gradient. Again, something which is applied in all cases, because all movements have some heavy vehicles, right? And the road have gradients as well. How to calculate the factor? This is the equation. These 2. The first 2. Okay. The first one only for downward gradient, and this is for upward all level. In this equation, we are using percentage of heavy vehicles and percentage of grade. PHV, percentage of heavy vehicle, PG, percentage of grade. Okay. Now you can see I am dividing the equation by 100. I am dividing the equation by 100. So if my gradient is 2%, I'll put what here? 2. Okay. You will put 2. I am not sure when you say 2% what you are thinking. Okay. So we will put what? 2. Okay. Then factor for parking. Not always. Okay. And even if parking is present, it will be on which side?
Right side. Must be right side.
Must be right side, right? Unless you want, then we can park anywhere, right? Take a sip.
Hurry. Hurry, what can you?
Okay. So it will be on the right hand side lane. Yes, if a road has 3 lanes and there is a parking available, you don't have to apply this factor to all the lanes. Okay, it's for each lane, because we have, remember, we have lane groups, right? We have lane groups. So you may have a lane which is on the right hand side and it will only affect that lane group, not the others. Okay, so keep it in mind. How do we do it? How do we calculate the parking adjustment factor? This is the equation. This number is very small, but it is NM. Okay, what is NM? Number of parking maneuvers. Parking maneuver are 2, going in, coming out. Okay, so how many in the peak hour or in the hour which when you are doing this? Okay, so number of maneuvers and number of lanes, again, number of lanes where? In your group, in your lane group. Okay, keep it in mind. Saturation flow rate is for each lane group. So if your lane group has 2, okay, then 2. Clear? Okay, and will be 2, not n. Okay, then factor for bus blockage or bus stop only applied if you have a bus parking or a bus stop near the intersection, and this is how you will calculate it, where n is number of lane, same as this one. NB is number of buses stopping per hour, not coming. Okay, maybe 10 buses are passing, but all of them don't stop at this location. Okay, maybe only 2 of them are stopping. So NB will be 2, not 10. So this is not the one which you are getting in the whole volume. Okay. Area type, if it is a central area or not central area, only 2 values. If it is central area, just put 0.9. If it is not, you don't consider it. Okay. Factor for lane utilization, I already mentioned, right? What was this factor?
Percentage of each lane. If they go
Yeah.
out.
Okay. Percentage of movement in each lane, and this is taken from here. Okay. So what type of lane you have? Okay. And how many in this group? Okay. What type of movement you have? How many lanes you have? And this is the factor then. This is the percentage. Okay. And according to the percentage, the lane utilization factor is there. Okay. So you are looking for this value. These values are also used, but not here, not in this equation. We are looking for these. Clear? Okay. Now through means what? Straight. Okay. Exclusive through means only straight. Okay. Exclusive through means only straight. Okay. What else? Factor for right turning, factor for left turning. As I said, if you have a left turning group or right turning group, then you will apply these factors. What are these factors? 1 upon equivalency factor. Okay. Equivalency factor is this. These are given. 1.18 for right turning. Okay. And 1.05 for left turning. Okay. What do we mean by equivalency factor? We use equivalency factor for heavy vehicles, remember? Okay. So what was that?
How much the truck equal the cars?
Equal the cars. Same thing. How much? So now it is for left turning and right turning, right? So how much is left turning equal to through? And how much is right turning equal to straight? Okay. So these the values are fixed. Now the last 4 factors was the one which I was mentioning, because they are not standard values. They don't have one equation. Okay. They have a series of calculations which we are not covering. Okay. But they are given in the textbook. They are given in the highway capacity manual. You can have a look. One of them we already covered, which was for. Okay. So this is already covered in the previous chapter. Same calculations. Okay. And if you look at those calculations, you will see we need a lot of factors and 2-3 equations. Okay. So same is the story with the other 3-4 factors which we are not covering. Okay. So but these factors are there. Okay, let's say we want to find out the saturation flow rate for lane groups on the EB approach. EB means eastbound. Eastbound. Okay. Now which approach they are talking about? They only gave me volumes for one approach, right? So this is called as eastbound. Why we are calling it eastbound? Because it's towards east. Okay. If I say westbound, it means towards west. If I say northbound, towards skies, right? Towards north. Clear? We are giving the name according to direction where it is going. Okay. So because we will use it in the other questions. Okay, and it will be given for all directions. So don't get confused. You have to create this thing. Okay. What is this now? Cycle length is given. I don't know why. Okay. We have protected left turning phase. Lane width is given. Okay, lane width for left turning is 11 feet and for the others 13 feet. Okay, 3% heavy vehicles, 1% trucks. We have parking on the right curve with no vehicles moving in or out. So there is parking, but number of people going in and out in the peak hour, obviously, when this is happening, is nothing. Okay, so in the analysis period, there is no parking maneuver. Okay. Local bus stop on the far side. Far side means after the intersection. Far side means after the intersection. Okay, near side is before. So now you can see even if the bus stop is near the intersection after, we still have to apply the adjustment factor. Okay, so it is near the intersection, before or after, it's enough. We have to apply the adjustment factor. How many buses are stopping? 15. It's a non-CBD area, non-central area, and there are no bicycles here. Okay, did they give me any pedestrian data? No pedestrian data as well. Even if they gave me, we are not doing the calculations for that. Okay. First of all, I will pick a base value. Okay, base values are mentioned here. 1,900 for urban, 1,700 for rural. Okay, did they mention the area here? They did not mention urban or rural, right? Okay, but since it's a bus stop, I will say it's urban. Okay, rural areas usually don't have bus stops near the intersection, so I would say it's urban. Okay, for urban area, the base value is 1900. Now multiply the adjustment factors with 1900. Okay, the first one for lane width. My lane width is, now we have two lane widths, right? The base value will not change. I cannot change it because I'm just taking it from the area. If I was doing it with the headway, I can take or observe headway for the left turning and for the straight and even for the right turning. So I can have different values. In this case, I cannot. The base value 1900. I'm picking it from the standards as per the area. So all the lanes are in the same area. I cannot change it.
Use the average.
Huh?
Can I use the average vector?
Average for what?
Vector of lane.
No. We will not use average. If you start taking average, you can see how many factors we have. So it will create a big change. Okay, we cannot use average. But the point I was making about the base value, you can have a different base value for each lane group if you have observed it. Clear? Okay, the first factor is for lane width. Lane width is different. One is for 11, the other one is 13, right? Okay, so how many lanes I have, by the way? Tell me. 3 lanes, huh? So I need one for the left turning and the other one for straight and, they call it through, and right. This value will remain the same. Okay, lane width adjustment factor. Lane width, left turning 11 and the other one 13. So for left turning 11 is in this range. Okay, so the factor is 1. For the other lane, it is 13. So it's in this range, so 1.04. Okay, then I have factor for heavy vehicles and gradient. Heavy vehicles 3% and gradient 1%. They did not separate between the lanes or the movement, heavy vehicles. Okay, so I will just calculate one factor and will use it in all the equations for both cases. Okay, so the what? FHVG. Since they mentioned with a positive sign, so we will assume that's upward. Okay, we'll use this one. So PHV is, how much was it? 3%, and this one is 1%, right?
Yes.
1. Okay, how much is the factor? This one. We'll use, yes, this equation. So this is 100, this is 0.78, this is 0.31. How much is it? You finished with your senior? That's why you're talking. Okay. He took traffic with me, I did not even hear his voice. Okay, next one is for parking. Okay, for parking I should know the number of maneuvers, right? They said no maneuvers in the analysis hour. Okay, so NM will become 0. Okay, now the number of lanes are different, N is different. N is different. Okay, one group has 2 lanes and the other group has 1 lane. Okay, so FP for left turning. Okay, so NM you will put NM as 0. And what is this? This is 18. 18 and 3600. Where is my bag? Yeah, bring my bag or not? Now remember, for left turning there are 2 lanes, N is 2. For the other one it's 1 lane. So how much we are getting? FP 0.95, and for the other one point how much? 0.9. Okay, so you can see here, even if I don't have any parking maneuvers, this is with 0 value, right? NM was 0. Even then we can have a factor. Okay, it's not like the factor will become 0 or 1. Okay, the next one is for bus blockage. Okay, so we need N, you already know N, 2 and 1, and we need number of buses which are coming, stopping in the analysis hour, just 15. 15. For which one? Left turning? 0.97. Okay, the next one is a factor for area type, again only to be used if it is central area. It is not central area, we will ignore this factor. The next one is for imbalanced utilization. We only have this problem in 1 lane group. Okay, which one is that? We can only have a problem of lane utilization with 1 lane group. Which one is that? These two, right? You can only divide the movement in these two. Okay, this is only 1 lane for 1 movement, so there is no problem. Okay, there is no lane utilization here. Okay, so as we will take the factor from here, exclusive left turn lane, 2 lanes, the factor is 0.97. So FLU is only for left turning, 0.97.
For the parking area,
Hmm.
we could calculate for both lane group or just for the right
For what? Parking? What they do? They calculate for both of them? No, no. Only for the right. Only for the right. This was the one, right? Only for the right. Sorry for that. Parking should be only for the right. So lane utilization only for the left because we have 2 lanes there. Okay. Then we have a factor for right turning, factor for left turning. Well, obviously one lane has right turning, the other one has left turning. So we will use both these factors. So what is this? Ratio 1 upon 1.18, 1 upon 1.05. How much is it? Factor for left turning.
Point 0.85 and
0.85 is for
the right turn. 0.85 for right turn.
okay. This one is 0.95. Okay, if there was a through lane, extra through lane, only through lane.
For right, 0.85 for right.
If there was an extra through lane only, then none of these factors will apply there. Okay, if there's a lane which has only through movement, then no left turning, no right turning. That for that lane group, we will not apply any of these factors. Clear? Okay? Clear or not?
Again, it's not.
Huh?
Again, what?
We have 3 lanes here, right? All these 3 lanes either have left turning or right turning. So you have to use the left turning factor for the first 2 lanes and the right turning factor for the last lane, right? But if I add a lane which is only for through movement, then that lane will not require any left turning or right turning factor, right? Okay, so this is what I'm saying. And what else? Which other factor we have? We have work zone factor is there, calculations we have done in the last chapter, but it's not given here. And okay, that's it. Okay, so give me the saturation flow rate adjusted value. Okay, so left turning will be multiplied by 0.97. And what else? 0.97 for the heavy vehicles and gradient, 0.97 for the bus. No, not for the bus, sorry. Again, same rule. The bus will not affect the left turning. Sorry. Only right. The bus stop is on the right hand side, right? So, not affect. Okay, what else? Left turning utilization factor, it was 0.97. And then we have the left turning factor, which is 0.95. For the right turning and through, we will have the 1.04 is for the lane width. Then we have heavy vehicle and gradient, which will remain as it is. Then we have one for parking. Then we have one for where was it? Bus. Bus stop. Then we have which one? 0.85 for the right turning adjustment. Yes.
So let's turn 1698.
Passenger cars per hour per lane is default. Okay, it's default. This equation or even the base value 1900 is passenger cars per hour per lane. Okay.
1378.
Okay, so the only thing you need to take care about is the applicability of the factors. Which factor will apply where? 2 factors without any exception will apply everywhere. And these two factors are which ones? Lane width and heavy vehicle and gradient. Okay, clear? Done? You will also want to take? Done? Good picture. Okay. The next thing we need to know is the proportion of vehicles arriving on green. Okay, the percentage of vehicles which they arrive, they find green signal. Okay, so it depends upon two things. It depends upon two things. Two things. The type of arrival you have and the spacing from the other signals. Okay, type of arrival is explained here. What type of arrival you have is explained here, and it's coded with a number. Okay, so 1 means most of the arrivals are during red, 2 means less extreme version of this one, 3 means a random arrival, and so on. Okay, the explanation is given. What do they mean by each arrival type? Okay, but it's coded with a number here. And the second thing which affects is the spacing with other signals. Okay, so and this is again on the basis of these two, then you find out the progression type. Okay, so proportion of arrival during green is p value. So I am trying to find out what p value. I need a factor which is called as the platoon ratio, RP. Okay, what is RP? Platoon ratio. Platoon ratio depends upon arrival type and signal spacing. Okay, now what is the platoon? Platoon is a group of vehicles which are moving from the intersection together. Okay, so platoon ratio tells you like from the flow how much is going together from the signal. Okay, and depend upon arrival type and signal spacing. Okay, so look at the arrival type, look at the signal spacing. Okay, then you will find out the platoon ratio. Okay, then RP value will be put in this equation to find out P, percentage of vehicles arriving during green. Now what is the small g? Green phase? No. Yeah? No, no.
All green.
Huh? All green. All green. Huh? Say again. Yeah, say it. Effective green. Why were you laughing? It's the correct answer. Everybody started laughing. She said effective green, or she said all green, and nobody is even bothered. All green. You know the meaning of all green? Huh? All green for 1 second, then it will become all red. Because everybody will be hitting each other. Okay, effective green, yes, effective green. Green time or the phase time minus lost time. Okay, effective green. And capital C is the cycle length. Okay, and how do we define cycle length? Tell me. Cycle length is what? Red to red. Okay.
Summation of all phases.
Summation of all phases. Very good. Everybody is woken up now. It's the end of the class, right? Yes. Okay. So just remember, we are going through the phases of the steps for the operational analysis of signals, meaning finding out level of service for the signals. We have discussed input data, and it requires you to find out lane groups and movement groups as well. Then we discuss saturation flow rate, the base value and the adjusted value. And then the next thing we want to know is proportion of vehicles arriving during green, and depends upon RP, platoon ratio, effective green time and cycle length. Clear? Again, effective green time will not be same for all phases. So that means P value will not be same for all phases. Clear? So it's not for you are doing it for the whole signal.